Again, my name is Bob Stefanski. I work for the World Meteorological Organization. As important, I work with Valentine Ike from the Global Water Partnership, and the Integrated Drought Management Program has many partners, over 47, but I'll get into that in a little bit. So I'll give a brief overview of IDMP, and then we'll talk about drought impact reporting and what we've been doing. Make sure the slides work here. There we go. So I think most of you know, droughts are among the most complex natural hazards, a creeping phenomenon. Actually, I want to probably update this third one, lack of precise or universal definition. We do know, depending on the impacts, when a drought begins and ends. But I think as an overall issue, some people are still uncertain of the definition of drought, but we're trying to work on that. Again, we're trying to use one term for many different impacts across the world, and that leads to some confusion. So how do we go from crisis management on drought to risk management? We develop integrated monitoring and early warning systems, improvement in applications of seasonal and shorter-term forecasts. I think a very key point is development of preparedness plans or policies. They can be at a national level or a subnational level. Adopt mitigation actions on drought. Again, this is different than the climate change mitigation actions. How do we lessen the impact of drought? That's what we're talking about. And then how can we provide countries and regions with a organizational structure and coordination within and between levels of governments and stakeholders? So the IDMP started in 2013 after the high-level meeting on national drought policies. We have 47 partners. We have a help desk. I'll have a link later below. We have a community of practice, and we do many trainings such as this and interactions with various stakeholders. We have actually over 47 partners, and key ones, FAO, United Nations, and of course, EOTEC. This is going to be a timer on my screen. We had a meeting last October and September, the Drought Resilience Plus 10 conference. And what are the key takeaways? I hope Martina and Aaron, you can share the presentation with colleagues. I suggest you hit the QR code to get all the conference conclusions and recommendations. We had 9 work streams, and I think it's quite useful to see what the international community is looking at this, and we had various other case studies. Some key points here, crucial need to mobilize resources and strengthen political will. Also, drought action is central to sustainable development, climate adaptation, and early warnings for all. So we have 3 pillars, and the pillar 2 is what the subject of today is about, drought risk and impact assessment. And you can see the other 2 pillars here on monitoring, early warning, and pillar 3, risk mitigation, preparedness, and response. When we talk about risk, we have the 3 aspects here of the vulnerability, hazards, and exposure. But we're talking about how do we get these impacts? How can we look at these? So one thing we've done, again, and I'll show some slides, again, from Kelly Smith from the University of Nebraska's National Drought Mitigation Center. Here's the baseline publication on baseline assessment of drought impact monitoring. This presents an overview. It has some case studies and a regional basin level, national and sector specific contexts. Again, identify some good practices. Again, we provide this as a entry point for countries to look at this. Again, one size does not fit all, but the purpose of today and other meetings like this is to share information to where countries can maybe adopt some of these practices and also talk to colleagues who are undergoing similar activities. Again, there's a QR report to read the report. So why monitor drought impacts? Again, this is to develop a comprehensive impact and loss in different sectors. Again, we find that officials tend to underestimate drought impacts. Trying to have some kind of ground truth to train the models, and also to justify mitigation actions. Again, we're trying to get some quantitative information. Again, this is from Kelly Smith's presentation that she gives, and she's one of our experts in this field. So what are some of the considerations in finding and using drought impact data? There's some questions there. Is your purpose academic or applied? Who is making what decisions? How does the data collection fit into a political process? And do they need more data? And if so, what? So again, I encourage you to take a look at this at your own leisure. A key challenge with drought impact data is that it just doesn't spring into existence. It needs a coordinating agency or organization. And a key question to ask, maybe this data already exists. So Kelly, again, you can see the link to the baseline assessment report, again, that Kelly did. I'm going to go through these 5 different impact collection systems. So we found event-driven databases, in situ condition and impact monitoring, which includes crowdsourcing, citizen science, and trade observers. 3, media monitoring, scraping news and social media, and I'll talk about that. Again, in the drought field, we look at food security, food security and water security monitoring. Again, these systems are built to solve a specific problem. And 5 is the data may show a drought signal, such as crop yield, hospital admissions, and insurance claims. So I'm going to quickly just go through the 5 of these as examples. Again, I can make a whole, longer talk. Again, this is just an idea to start the conversation during this hour and a half during this session. Again, number 1, event-driven databases. There's some examples from Europe, from the US, from the Caribbean. Again, characteristics are these might be top-down, maybe centralized. The uses can be research, historic, using mixed methods. Some of the limits, it takes staff time, uneven coverage, highlights extremes, outcomes, and rather antecedents. Number 2, the in situ collection and condition monitoring. Again, some examples, and I encourage colleagues to take a look at these. We can provide some links, but also can do a Google search. Examples, the Czech drought monitor, Australia, the Brazilian one, Canada. The US has this condition monitoring observing reports. Again, this is collecting observations from farmers, agencies. It includes citizen science, crowdsourcing. It does detect emerging conditions. Some of the limits, recruiting issues, can you retain people and keep volunteers motivated? And there is some issue with bias and sometimes motivated observations. Example from the Czech Republic. Again, this is looking at soil drought and impacts on crops. They do an online questionnaire. Again, I encourage you to look at the baseline document and also the presentation. And of course, you can send me an email with any specific questions as well. Number 3, sort of media monitoring, scraping news and social media. Again, people will use, I'm not sure I'll call it AI, but some mechanisms to look at all the different news activities and look for keywords such as drought impacts. Again, some examples here in the US, the European Joint Research Commission drought. Again, the Czech media as well. It can be used as a leading indicator. It's a rough draft of history. Sort of the limits, low signal to noise ratio and still somewhat conceptual, excuse me. Here's an example from the US Drought Impacts Toolkit. Again, looking at all the media outputs. Again, there's a link to the Bulletin of American Meteorological Society publication published in 2020. Again, Kelly Smith was an author of that as well. And again, you can see the links below as well. And I encourage you, and I can share the presentation afterwards. Some examples on the food security and water security monitoring. I think a lot of you are familiar with FuseNet. Also the UN FAO food security and nutrition analysis. There's one in Somalia, also one in Kenya, an example from the state of California. Again, this is looking at early warning of drought-related outcomes. These are purpose-built systems for a specific idea and purpose. Again, targeted, it looks at food aid, and targeting water deliveries. And then finally, number 5 is the data that may show a drought signal. This is repurposing data collected by agencies, producer organizations, and regulatory agencies. Again, some of these data sets include crop yield, disease tracking, tourist visits, energy production, and wildfire. Again, this is what some of the people around the world have been using. So putting it all together, there was a good example of this from EUDORA. The European Drought Observatory of Resilience and Adaptation has developed a methodology. Again, you can see the link to the paper there in 2023. This is from the European Drought Risk Atlas. Again, they have some good ideas here and concepts that could be useful for your specific purpose. So, the key questions: who feels the effects of drought? What regions are most vulnerable? What sectors are most vulnerable and most critical? And also, we have a companion publication. We have the baseline assessment. We're also developing with Kelly and our colleagues around the world a guidelines on drought impact reporting. If you're interested in reviewing this publication, please send us an email, and we're happy to include you in this review. I just want to quickly add, we have an IDMP community of practice. Again, we can share the link as well. I'll put that in the chat as I stay online. We have currently 241 members. Again, this is a drought community of practice around the world. And finally, here's the website and our email.
First, my name is called Abebe Kebede from Arba Minch University, as it is mentioned previously. My main expertise areas are drought and precipitation prediction, especially. So, as you know, drought is common phenomena which impacts the Horn of Africa region and across the world. So, I would like to present drought impact monitoring over East Africa region. Next step, sorry. Okay. Drought, when you can see, drought is a devastating phenomena. It affects community, agriculture, environment, as well as the hydrological sectors. And when it comes to across East Africa, especially, there is water resource management system. It requires further emphasis. Therefore, working so far on water resource management during a drought condition is very important. So this drought affects especially the water resource across East Africa and also the globe, as we have seen. Regarding to data, when you can see data is the main thing, since data is an information to monitor or early warning. Information of data is very important. So accurate data for a region of East Africa especially important. Rather than using low resolution satellite products, it may be better using high resolution satellite products and as well as a model. So based on this, as observation systems and climate models are basically very important for drought impact monitoring, and having other new technologies also, it is another additional input like machine learning is basically very important. Having machine learning, it is very, very important to monitor a drought as well as forecasting drought as well. Next step, please. Next slide, thank you. When you see droughts can be occur due to climate variability. It is obviously known, but people can, or researchers can define drought in different aspects also based on different factors. But when you can see a drought can be classified into meteorological drought, agricultural drought, hydrological drought, based on it is severity and duration. So when it comes to meteorological, agricultural, hydrological, and also socio-economic drought, since it is classified based on this, on duration and severity, it has an impact. It is impact observed on economic sector, social social impacts, and also we can see that environmental impacts. Therefore, when you can see that there is a propagation of drought in addition to this, the meteorological droughts propagate to agricultural drought, hydrological drought to that of socio-economic drought. There is a propagation of drought based on its severity and duration as well. Next slide, please. When you can see, a drought has its own threshold value. Droughts mainly based on different variables. It has its own threshold value. For example, precipitation, standardized precipitation index has, it is approximately -1 value below that, which coins a drought. So when you can see that the drought, to deal about drought events, drought persistency time, onset, offset of drought, basically understanding the characteristics of drought is very important. So this can be presented to you as an example using standardized precipitation. Next slide, please. Here we can see that in the previous time, just starting from 1950 to the present time, the drought frequently happened over East Africa region. However, starting from the end of 2020 to that of 2023, there was an extreme severe drought happened in the East Africa region. Therefore, giving an attention for such type of drought is basically important, since it affects the life of the people, the socio-economic over the region due to deficit of water. Therefore, it needs further emphasis. So here, when you can see that the drought situation is increased in spatially across and temporally here, as we have seen, mostly the last 22 years, that means the last almost 2022, 2005, 2022, 06, we can observe that in different parts of Ethiopia, Somalia, Kenya, and western parts of East Africa severely affected by droughts. Therefore, studying such type of phenomena or effects of drought which affects the socio-economic and the life of the people over the region, it needs to investigate further through teleconnections, that mean based on sea surface temperature anomalies like El Nino and IOD phenomena as well. Next slide, please. Okay, thank you. The next is soil moisture anomaly. When you can see that the soil moisture anomaly, it varies based on when you can see that starting from 2021 to that of 2022, 06, the soil moisture anomaly, it varies. So it indicates for us the drought occurrence as previously mentioned using the precipitation drought index using standardized precipitation index for certain months. Again, similarly, the soil moisture indicates the deficit. Such deficit which affects the agricultural sectors, that means it's reduced the yield can be indicated by using soil moisture anomaly as you have seen here. Next slide, please. This is the drought. We try to develop a new drought index over Ethiopia to understand the importance of new drought index. As we have known, just developing a new drought is challenging, even starting from the way how we can use. It requires many trial and error. Just we developed using 5 variables combination. First, we did a formula. We developed a new formula which assimilates 5 variables. That variables are precipitation variable, potential evaporation, soil moisture, surface temperature, and also soil temperature. Including these variables, we created a formula which assimilates these values together. And then based on this, we developed a new drought index, as we have seen, multivariate standardized drought index, here depicted for 12 months time scale, as we have seen. So across each month for the time scale 12, it indicates a good result in agreement with that of the previously observed drought indices over Ethiopia. And in addition to that, when you can see that in 2022, there was an extreme severe drought, especially southern and southeastern parts of Ethiopia. So we worked so far based on that, and this new drought index captured this extreme severe drought over southern and southeastern parts of Ethiopia. So I recommend that maybe if it extended to East Africa, it is better in near future. I think I'm happy to work so far on this. Please, next slide, please. The next indicates for us, we try to compare the new drought index in comparison to that of the existing droughts. Previously, we can work on using standard precipitation, standardized precipitation, soil moisture, standardized soil moisture index, and also the combined of the two, that means multivariate standardized drought index, which is developed by Amir and Aguacho in 2015. So this drought, the new drought index compared with the previous drought index, and it captures well across the Ethiopia region. We try to temporarily it captures, as we have seen. Next slide, please. The other is what we try to see here is the boron allocation. As you have known, boron allocation is one of the affected region during 2021 to that of 2023. There was extreme severe droughts, so many cattle lost their life. In almost 3.2 approximately millions of cattle died due to a drought. Therefore, it needs many emphasis. So with this index, this new drought index captured this region, the occurred drought index, the occurred drought over boron allocation. Therefore, maybe in near future for monitoring and to prediction of drought, this index can be used. Next step, please. Okay, thank you. The other is what we can see here, the Upper Blue Nile region. When you can see that the Upper Blue Nile region, which is located in Ethiopia, it has a water resource and it feeds the Nile River about 86%. Therefore, giving an emphasis to monitor the water resource over this region is basically very important, since droughts occur over this region. And what we have seen here, there is rainfall, runoff, and in addition to that, soil moisture. There is a lag association among each variable, when you can see that, as we have seen the right side of the plot. Next step, please. Thank you. So this again, over Upper Blue Nile region, we did the first is indicates for us the time scales, 1 to that of 12 time scales. Based on the time scales, we temporarily we try to evaluate our new drought index. We developed over Upper Blue Nile region 2 drought indices. One is without climate information, another is with climate information. So this investigation is published on spring. You can find it over there. Even I can provide you a link. So these 2 drought indices are very captured the drought condition over Upper Blue Nile. So the new drought index by combination of the 4 variables together, one based on local variables, the other index which contains including the global information or global signals. That means the sea surface temperature, NINO 3.4 region. NINO 3.4 region, it have during El Nino and La Nina, it shows its effect over Ethiopia. Therefore, why we can consider that. Next step, please. Thank you. Here, when you can see this, this part indicates for us, we classify the upper Blue Nile into 2 parts based on its climatic condition, and we try to again see these 2 drought indices, their performance with that of we compared with the standard precipitation index. When you can see here, these 2 drought indices, their performance, especially, they can able to capture the severity of drought across a time series, as we have seen here, the green color and the black color. Next step. Lastly, I would like to say thank you very much for your attention.